Take a look at this split-screen comparison. On the left is how almost everyone interacts with AI, typing a prompt, copying the answer, pasting it somewhere else, and repeating the cycle for every single task. On the right, a spreadsheet populates entirely on its own. Our objective today is to get you out of that manual loop. We are going to take a blank chat box and translate it into a structured framework that runs an assistant in the background. To execute this build, you need three things: a premium Claude account or API access, a third-party integration platform, and a strictly defined repetitive task you want to offload. As long as you rely on the standard chat interface, your output is capped by how fast you can type and copy. Building an autonomous workflow removes the human bottleneck entirely, creating true, scalable leverage with AI. Step 1 is establishing a persistent memory so the AI retains your operational rules. We do this by moving out of the temporary chat environment and creating a dedicated project workspace. This is the Claude Project's knowledge base menu. Instead of retyping your preferences every session, you will use these upload buttons to deposit your core instructions and context documents directly into the system's static memory. Warning tone: keep dynamic, frequently changing data out of these foundation files. This space is strictly for permanent rules, like formatting guidelines or company voice. Once uploaded, look for the visual confirmation checkmark next to your files. That indicates the knowledge base has successfully ingested your rules. By establishing this persistent memory, you prevent the context window from failing over time. You completely eliminate the need to re-educate the model every time a new task begins. Now that the system has instructions, we need to give it the ability to execute them. This happens over in your integration dashboard. Look at this integration settings panel. To allow the AI to interact with your other applications, you must explicitly select and enable tool use from this drop-down menu. This diagram shows exactly how the handoff works. We are mapping Claude's cognitive output directly to the specific input fields of your target application. Notice the strict unidirectional flow here. The assistant formats the data and pushes that standardized packet forward into the external database. Before you fully automate this bridge, you must execute a manual test run to catch any mapping errors. Open your target application. If you see a newly generated draft or a correctly formatted database entry, the connection is successful. Configuring tool access shifts the role of the LLM. It goes from being a passive advisor waiting for your questions to an active participant doing the work. The final step is replacing your own manual prompts with an automation trigger. At the top of this flowchart is your automation trigger, a timer or an event like a new email. When that trigger fires, it forces the assistant to wake up and immediately consult its persistent memory. Following the rules in that memory bank, the assistant moves down to utilize the connected external tool. After the tool runs, the system logic resolves and safely returns to a dormant state, waiting for the next trigger. The primary failure point in this setup is the system getting trapped in an infinite loop, repeating the execution phase because it doesn't know the task is finished. To prevent that, look at this system prompt field. You must write a strict completion condition, like, once the data is logged, stop and await the next trigger. With that safety parameter in place, you can hit publish and activate the complete workflow. Activating this loop changes your daily routine. You are no longer an active task operator. You are a high-level system supervisor. With the system live, you can watch it work. The trigger fires. The assistant pulls context from memory, executes the tool, logs the data, and rests. It runs multiple cycles flawlessly, entirely on its own. You have successfully engineered a self-running assistant and completely bypassed the blank chat box. From here, the architecture is ready to scale. You can expand the memory bank to handle more complex logic, or layer in secondary tools to execute multi-step routines. By combining persistent memory, tool access, and an automation trigger, you built a system that functions without human input. True utility in artificial intelligence is found right here, by designing autonomous systems rather than typing out manual interactions.